Turbomachinery, Francis turbine. What is turbine? Turbine is a prime mover that converts fluid potential energy into kinetic energy and thus mechanical energy. It is then converted to electricity by a generator connected directly to the turbine shaft. Based on the reaction of movement of water to the blade, the turbine can be divided into two main types. One is reaction turbine. The example of reaction turbine is Francis turbine. It requires low flow and high flow rates. And the other type is impulse turbine. The example of impulse turbine is Pelton wheel. It requires a high volume and a small quantity of water. We will discuss both types of turbine. Third, Francis turbine. James Bicheno Francis, 1815 to 1892, was a British-American civil engineer who invented the Francis turbine. James also became fascinated with and tinkered with turbine design after Uriah Boyden first demonstrated his Boyden turbine in Lowell. The two engineers worked on improving the turbine. In 1848, Francis and Boyden successfully improved the turbine with what is now known as the Francis turbine. Francis turbine eclipsed the Boyden turbine in power by 90%. In 1855, Francis published this finding in the Lowell hydraulic experiments. This is the main component of Francis turbine. 1. Volute or scroll or spiral. It is located in here. The volute in Francis turbine is similar with the volute in centrifugal pump. It was created to avoid eddy. The cross-sectional is maximum at the inlet and minimum at the outlet. Number 2. Guide vane, also known as guide wheel. This blade controls the water into the volute to suit the runner's design. We will see the location of guide vane in the next chapter. Number 3. Runner. The water reaction on the blade produces rotating moment on the runner connected to the turbine shaft. In Francis turbine, blade here is known as runner. However, in centrifugal pump, blade is known as impeller. Number 4. Draft tube. A channel that connects the output of the runner to the tail race. The cross-sectional area grows slowly as it allows the turbine to be mounted on the tail race without altering the existing turbine. It will also increase the efficiency of the turbine by adding negative pressure to the turbine outlet through the draft tube. So this is the draft tube. It is normally created or designed bigger at the end here to make sure that water will flow out easily. This is some example of Francis turbine. You may find a lot of examples of Francis turbine in textbook and also from the internet. This is the velocity of Francis turbine. We will learn about velocity triangle in the next chapter. And this is the Kaplan turbine. Kaplan turbine is a propeller-type water turbine which has adjustable blades. It was developed in 1913 by Austrian professor Victor Kaplan, who combined automatically adjusted propeller blade with automatically adjusted wicket gate to achieve efficiency over a wide range of flow and water level. The Kaplan turbine was an evolution of the Francis turbine. Its invention allowed efficient power production to low head application, which was not possible with Francis turbine. The head ranged from 10 to 70 meters and the output ranged from 5 to 200 megawatt. Runner diameter are between 2 and 11 meters. Turbine rotate at a constant rate which varies from facility to facility. That rate range from as low as 44.5 rpm to 450 rpm. Kaplan turbines are now widely used throughout the world in high flow, low head power production.